Hi, Assalamualaikum. We are going to discuss question self exercise 2.10. Okay, textbook page 62. Okay, question number 1, find the coordinates of the turning point. Okay, so turning point, clue here, turning point, dy dx equal to 0. Okay, so then you have to identify the turning point is maximum or minimum. Okay, so A, y equals to x cube minus 12x. So turning point just now, I said dy dx equals to 0. So we differentiate dy dx equals to 3x squared minus 12. Okay, equal to 0, x squared is 4, x is plus minus 2. Okay, so coordinate. If coordinate, you must find the value of y. Okay, when x equals to 2, y is 2 cube. Okay, cube minus 12 times 2 equals to negative 16. So here we have coordinate, one coordinate. Okay, 2, negative 16. Okay, another value of x. So when x equals to negative 2, y is negative 2 cube minus 12 times negative 2. Okay, which is 16. Okay, so therefore, the second coordinate is negative 2, 16. Okay, so these two coordinate, you have to identify which one is maximum and which one is minimum. Okay, to identify the maximum minimum point, we have to differentiate another time. Okay, find the second derivative, d squared y dx squared, which is 6x. Okay, so then we substitute. Substitute when x equals to 2, d squared y dx squared is 6 times 2, which is 12. Okay, 12 is more than 0. Okay, so smile meaning that minimum. So therefore, coordinate 2, 16. 2, negative 16 is minimum point. Okay, so when x equals to, negative 2, so d squared y dx squared equals to 6 times negative 2 is negative 12, less than 0. Okay, so when less than 0, we have maximum. Okay, so therefore coordinate negative 2, 16 is maximum point. Okay, done. Question 1b. We have y equals to x minus 6 squared. Find the turning point, so differentiate equal to 0. Okay, in this situation, we have two alternative ways. Either you use product rule or you expand, then you differentiate one by one. Okay, so I prefer expand first. Okay, so here I have x squared minus 12x plus 36. Okay, so here I have x cubed minus 12x squared plus 36x. So therefore, dy dx is 3x squared minus 24x plus 36 equals to 0. Okay, this is quadratic equation. So to solve, you factorize. Okay, looks like you can factorize 3 first. Okay, so here squared minus 8x plus 12. Okay, so here I have so x minus 6. Okay, x minus 2. Okay, so here I have x6 and x equals to 2. Okay, to find coordinate, substitute x into y. So when x equals to 6, y equals to 6 into here. Okay, into y. Okay, so 6 minus 6 squared, which is 0. So here the first coordinate is 6, 0. Okay, the second one, when x equals to 2, y is 2 minus 6 squared. Okay, equals to 2 minus 6, negative 4 squared, 16 times 2, 32. So the second coordinate is 2, 32. 2. So then to identify this coordinate maximum or minimum, you have to differentiate another time. Okay, dy dx right here. So d squared y dx squared is 6x minus 24. When x equals to 6, d squared y dx squared is 6 times 6 minus 24. Okay, 36 minus 24 is 12. Okay, 12 is more than 0. Okay, so minimum. Okay, so therefore coordinate 60 is minimum point. Another one, when x equals to 2, d squared y dx squared is 6 times 2 minus 24. 12, okay, minus negative 12 is less than 0. Okay, so maximum. So therefore coordinate 2, just now 32. Okay, so 32 is maximum point. Let's do next question. C. Find turning point. So turning point dy dx 0. Here we have y equals to x square root 18 minus x squared. Okay, so you have to use product rule. U is x, du dx is 1, v is 18 minus, x squared power of 1 over 2. So dv dx is 1 over 2, 18 minus x squared, power of negative 1 over 2 times negative 2x. Okay, so this one become negative x over 18 square root 18 minus x squared. Okay, so find du dx, dy dx. So dy dx is u dv dx. So negative x squared over 18 minus x squared plus, okay, square root 18 minus x squared. Okay, so to simplify this, you equate the denominator. Okay, so square root 18 minus x squared times square root 18 minus x squared. Okay, so this one become negative x squared plus 18 minus x squared. Okay, over square root 18 minus x squared. Okay, so we simplify, we get 18 minus 2x squared over square root 18 minus x squared. Okay, this is dy dx. Okay, so turning point dy dx equals to 0. So u equals to 0, we get 18 minus 2x squared equals to 0. 2x squared equals to 18, x squared equals to 9, and x equals to plus minus 3. Okay, coordinate, find x and y. So when x equals to 3, y equals to 3 square root 18 minus 3 squared. Okay, so 3 times 3 is 9. Okay, so when x equals to negative 3, y is negative 3 square root 18 minus negative 3 squared. Okay, equals to negative 9. Okay, so here from the first one we get coordinate 3, 9. And the second one, negative 3, negative 9. Okay, so to identify this one is maximum or minimum, you have to differentiate another time. But this one is quite long, so I leave it for you to try yourself. Okay, D Find turning point for y equals to x minus 6, 4 minus 2x. Okay, in this situation, you may use product rule, but I think I prefer to expand one by one first. This one become 4x minus 2x squared minus 24 plus 12x. Okay, so then I simplify. I get here negative 2x squared plus 16x minus 24. So then here we go. We can differentiate one by one. So negative 4x plus 16. Okay, turning point, dy dx equals to 0. Then we get x equals to 4. Okay, then we substitute x4 into y. We get here any one. Okay, so let's say I choose the third one. So I get, wait, okay, so negative 2 times 4 squared plus 16 times 4 minus 24. Okay, here is 8. So the coordinate is 4, 8. Okay, so then to identify this 4, 8 is a maximum or minimum, I differentiate another time. So here I get d squared y, dx squared is negative 4. Negative 4 is less than 0, so maximum. So therefore, 4, 8 is maximum point. For question 1e, y equals to x plus 4 over x. Okay, so to find turning point, differentiate. Equal to 0. So we differentiate. Before that, we move up. So here we have dy dx is 1 minus 4x power of negative 2. Okay, which is 1 minus 4 over x squared equals to 0. Okay, so x squared equals to 4. Okay, so then x equals to plus minus 2. Okay, find point. So substitute into y. So when x equals to 2, y equals to 2 plus 4 over 2, which is 4. So the first coordinate is 2, 4. Okay, then when x equals to negative 2, y equals to negative 2 plus 4 over negative 2, which is negative 4. So the second coordinate negative 2, negative 4. Okay, so to identify which one is maximum minimum, you differentiate, find the second derivative. So d squared y dx squared, okay, become 8x power of negative 3. Okay, so 8 over x cubed. Okay, when x equals to 2, d squared y dx squared is 8 over 2 cubed, which is 1. 1 is more than 0, so minimum. Then 2, 4 is minimum point. Okay, but for x equals to negative 2, d squared y dx squared, 8 times negative 2 cubed is negative 1, is less than 0. So maximum. Therefore, negative 2, negative 4, maximum point. G question. Okay, y is x plus 1 over x minus 1. Okay, turning point, dy dx 0. So we differentiate. Before that, we can simplify first. Negative 1. Okay, so dy dx is 1 minus x minus, this one is power rule. Okay, so power of negative 2 times 1. So 1 minus 1 over x minus 1 squared. Okay, equals to 0. So 1 equals to 1 over x minus 1 squared. So x minus 1 squared is 1. Okay, so x minus 1 equals to plus minus 1. So then here we can find two coordinates. Okay, the first one, minus 1 equals to 1, so x equals to 2. Okay, when x minus 1 equals to negative 1, x equals to 0. Okay, when x equals to 2, y equals to, okay, 2 plus 1 over 2 minus 1, which is 3. Okay, so the first coordinate is 2, 3. Okay, this one, substitute x0, 0 plus 1 over 0 minus 1. Okay, so negative 1. Okay, so negative 1. So therefore, the second coordinate is 0, negative 1. Okay, identify which one maximum minimum. So just now, dy dx is this one, Okay, from this, okay, d squared y dx squared, okay, equals to 2 x minus 1 power of negative 3 times 1. Okay, so which is 2 over x minus 1 cube. Okay, so you substitute, okay, when x equals to 2, d squared y dx squared equals to 2 over 2 minus 1 cube. Okay, equals to 2. Okay, so 2 is more than 0. So maximum. Minimum. Okay, minimum. Sorry. Okay, so minimum. So therefore 0.23 is minimum point. Okay, so when x equals to 0, x equals to 0, d squared y dx squared is 2 over 0 minus 1 cube. Okay, which is negative 2 is less than 0. So maximum. Okay, so coordinate 0, negative 1 is maximum point. For question H, y is x minus 3 squared over x. You may use a quotient rule, but I prefer expand. Okay, so x squared minus 6x plus 9 over x become x minus 6 plus 9x power of negative 1. So then find dy dx is 1 minus 9x power of negative 2. So 1 minus 9 over x squared. Okay. Turning point dy dx 0. So x squared equals to 9. X equals to plus minus 3. Then substitute into equation. So when x equals to 3, y equals to 3 minus 3 squared over 3. Okay, 0. So 3, 0. When x equals to negative 3, y is negative 3 minus 3 squared over negative 3, which is equals to negative 12. Okay, negative 12. So the second coordinate is negative 3, negative 12. Okay, differentiate another time to identify maximum or minimum. So this one become 18x. Okay, so d squared y dx squared is 18x power of negative 3. Okay, so 18 over x cube. When x equals to 3, d squared y dx squared is 18 over 3 cube. 18 over 27, 2 over 3. Okay, 2 over 3 more than 0. So minimum. Then coordinate 3, 0 is minimum point. Okay, when x equals to negative 3, d squared y dx squared 18 over negative 3 cube. negative 2 over 3 less than 0. Okay, so maximum. Then coordinate negative 3, negative 12, maximum point. Okay. Number 2, the diagram on the right shows a part of the curve y equals to x minus 2 cube. Okay, A, find an expression for dy dx. Okay, so when to find dy dx, differentiate, you need to use product rule. So u is x, du dx is 1, v is x minus 2 cube. So dv dx is 3x minus 2 squared times 1. So 3x minus 2 squared. Okay. So dy dx, here we have product rule. So u dv dx, so become 3x x minus 2 squared plus x minus 2 cube. Okay, to simplify, we can factorize, we choose the smaller one to move out. Okay, so become x minus 2 squared. So 3x plus x minus 2. Okay, so this one, x minus 2 squared for x minus 2. Okay, so we can factorize. Okay, 2 move out. So 2x minus 1, x minus 2 squared. Okay, so this is the dy dx. Okay, so next question B. Find the coordinates of the two stationary point. Okay, stationary point same with turning point, which is dy dx equals to 0. So meaning that you have to use the previous answer. Okay, this one. So make it equal to 0. So P 2x minus 1 x minus 2 squared. Okay, so equals to 0. So then 2x minus 1 is 0, x is 1 over 2. X minus 2 is 0, x equals to 2. Okay, here we have two values of x. So then you can find two values of y. Okay, you substitute into this one. Okay, so when x equals to 1 over 2, y equals to 1 over 2, 1 over 2 minus 2 cube. Okay, so here we have 1 over 2, negative 3 over 2 cube. Okay, so this one become negative 27 over 16. Okay, so the first coordinate is 1 over 2, negative 27 over 16. Okay, when x equals to 2, y equals to 2. 2 minus 2 cube. Okay, so equals to 0. Okay, so equals to 0. So therefore, another point is 2, 0. Okay, so to identify which one is, no need. Okay, no need. Because the question just asks you to find the coordinate of the two stationary point. Okay, no need to identify this is maximum or minimum. Okay, so this is the two stationary point. The last one, subsequently determine the nature. Okay, the nature of the stationary point Q by using the tangent sketching method. Okay, before we determine the nature of point Q, let's look at the point P first. Okay, look at the nature of the point P. Okay, if you draw the point P, okay, point P, this is point P. Okay, so you can see when x increases, the tangent. Okay, the tangent is the left side is negative. Okay, when at point P 0. Okay, and the right side positive gradient. Okay, when x increases, the gradient is changing from negative to 0 and to positive. Okay, so meaning that minimum point. Okay, this is for point P. Okay, for point Q. Okay, for point Q. So we draw point Q right here. Okay, so this is point Q. So look at the gradient. Okay, so the gradient from the left to the right. Okay, from the left, when x increasing, at the left side gradient is positive, then change to 0, then to positive. Okay, we can see the dy dx, the gradient changing from positive to 0 and then to positive again. There is no change in sign as x increases. Okay, so therefore point P, we call it point of inflection. So P is is inflection point.